Hi, and welcome to this section of the Matrix Algebra Tutor. And in this section, we're going to continue where we left off with the previous couple of sections when we did the addition and subtraction of matrices, and we also learned how to multiply a matrix by a scalar, basically by another number. That's what scalar multiplication is, okay? This time, we're going to expand our knowledge of how to deal with matrices, and we're going to learn how to multiply a matrix by another matrix, okay? Actually, matrix multiplication is usually what this topic is called, multiplying a matrix by another matrix. And it's really usually the first time that most people, when they're starting to study matrices and matrix algebra, where their head starts to spin a little bit, okay? I hope I've broken down the barriers in the first couple of sections of the class, teaching you that these matrix things really aren't that big of a deal. But when you get to the multiplication, a lot of times it confuses people because there's a certain way you have to do it and you have to follow the procedure right, or you get a completely wrong answer, and there's plenty of places to make an error. There are plenty of places to make a mistake, okay? So what you need to do with your matrix multiplication is practice, 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 and we're going to do a lot of problems here giving you that practice, but you need to practice on your own because there's a lot of little steps to it and sequences, and if you just are careless, then you're going to get the wrong answer and you're going to be mad at yourself because it's going to be a simple mistake usually, okay? So remember, big picture. We're going to use these matrices to learn how to solve systems of equations, okay? We've learned how to add them, we've learned how to subtract them, we've learned how to multiply them by a number. Now we're going to learn how to multiply them, matrix by matrix. And it turns out that that is actually required. Matrix multiplication is required in order to do any of these, into solving these systems of equations. It's very useful. It's very common. You will use this for sure as you continue on in your math, okay? So, most of the time when you get into a book on matrix multiplication, the first thing you do on page number 1 is they'll draw a matrix with a bunch of letters, usually A, I, J, etc., going on down, just kind of filling up the matrix with a variable, and they'll multiply it by another matrix with a bunch of other variables, and they'll write it out in longhand form how you do this multiplication. And it makes my head spin to watch that, okay? And I know how to do it, okay? So what I'm going to do, I'm not going to write a single matrix with variables in this section. They're all going to have numbers, and what I'm going to do is show you how to multiply them by examples, okay? By watching the patterns as we do them, you will get comfortable, you will understand how to do it, but you're going to do it not by just looking at a matrix full of a bunch of letters and hoping that it makes sense. You're going to do it by actually working the problems and seeing lots of problems worked out. So rather than talk about it anymore, I want to dive right into how to do this thing, okay? So the easiest way to do it is to jump in with an example. So that's what we're going to do here. Here is an example of what a matrix multiplication might look like. Here's matrix number 1. It's a simple matrix, 2 by 2. It has 2 rows and 2 columns. And right now, just for grins, I'm going to write that down under here. This has 2 columns. Okay, 2 columns, 1 and 2. And I'm going to write that down there because we're going to need to use that in a minute. Now, usually when you're multiplying matrices together, you don't usually write a dot in the middle. Normally when you're multiplying, 4 times 3, you put a dot in the middle. You don't really do that in matrix multiplication. It is implied when you multiply a matrix by another matrix that just because they're written next to each other without a plus sign or a minus sign, that they're actually being multiplied together. Okay, so let's say the second matrix we have is just something simple. 1, 2, 3, 4, 0, 2, -1, 6. This is supposed to be a 2 right here. Okay, and this is a matrix. And notice again, and I don't expect you to know why or even care why at this point, but notice that this matrix right here has 2 rows. Okay, so these two matrices are multiplied together just because they're written next to each other, and what you're going to get out of it is a matrix. I mean, a matrix multiplied by a matrix is going to return basically a matrix in the vast majority of cases. So that's what you just have to sort of get used to. When you multiply a number times a number, you get a number. You multiply a matrix times a matrix, you're going to get another matrix back. Okay. Now, the number one thing that you need to know that in the beginning here is going to seem like you're just going to have to memorize it and it might scare you off a little bit, but in fact it's just going to come with practice that you'll understand this. The only way you can multiply a matrix by another matrix, I rarely turn around and tell you to really pay attention and remember something. This is one of those times. Really pay attention to what I'm about to say here, okay? The only way that you can multiply these two things together is if the first matrix that's written first has the same number of columns as the second matrix has rows. Okay, let that sink in for a minute before we continue. The only way I'm able to multiply a matrix times another matrix is if the number of columns of the first matrix is exactly equal to the number of rows of this matrix. And you will see why that is the case. Right now, I know it seems like you're just going to have to memorize it, and you're like, well, geez, why is that the case? Well, I'm going to show you why that's the case from some examples, but that is the truth. That's what you're going to have to remember, okay? Now, just to give you an example, if this matrix didn't have 2 rows, let's say it had a third row and it continued down here with some more numbers down here, then this multiplication could not be done. It's very important that you know that. That means that if you tried to do this, even in a calculator, put this matrix in and then put this one in with a third row here and hit the button, the multiply button, it would give you an error. It cannot be done. It is not defined, okay? That's because matrix multiplication is a very special thing. You're going to see how to do it, and when I show you how to do it, it's going to make sense why these things have to be the same number of columns in the first matrix times a row in the second, okay? So I want to write that down because it is probably the most important thing that you're going to learn in this particular section, aside from the actual problems. The number of columns of the first matrix must, and I'm going to underline it, be equal to the number of rows in the second matrix in order to multiply. Okay, it's very simple. The number of columns in the first matrix must be equal to the number of rows in the second matrix in order to multiply them. You'll see why that's the case in a minute. If it's not true, if this thing had, another example, if it had 3 columns or 4 columns, 1, 2, 3, 4, let's say it was 4 columns. You tried to hit the multiply button in your calculator, it would say error, can't do that. And you might be left wondering why. Well, we're going to understand why as we go along here. Okay, now the other thing I want to point out to you before we actually get to the matrix multiplication, and you're going to see this through the examples as well, is remember back from second grade math. You learned that 2 times 3 is 6, and you also learned that 3 times 2 is 6. Now we take that for granted today, but at one time that was really new to you. That you didn't understand or really know that. You had to memorize that, okay? One time, a long time ago, if you search back, you learned that 2 times 3 was equal to 3 times 2, which is equal to 6. And that just means that multiplication of numbers, it doesn't matter the order in which you do the multiplication. It's the same thing for addition, really. 3 plus 2 is the same as 2 plus 3, right? We understand that. We know that because we've worked with numbers for so long. Well, this matrix stuff you haven't worked with for any length of time. So everything you learn about it in the beginning is going to be really foreign to you until you get to your hands dirty and start playing around with them. So why did I bother to even tell you this? Because in matrix multiplication, that is actually not the case, okay? That is actually not the case. So what do I mean by that? Matrix A times matrix B, these are both matrices, okay? If I multiply them, is not usually equal to B times A, okay? It is not equal to B times A. So that means if I take 2 matrices, okay, and I multiply A times B, if I put A in first and then B in my calculator, or by hand, when I'm doing it by hand, and I hit the button, I'm going to get a matrix back, okay? If I flip it around and put the second matrix first times the other one and hit the same button, or if I do that by hand, I'm going to get a different answer back. Okay, in a general case, I'm going to get a different answer back. Now, that may be completely foreign to you, and it should be foreign to you because numbers don't behave like that, and we've been dealing with numbers forever. Well, these aren't, I mean, these are matrices filled with numbers, but they're different constructs than numbers. Okay, so they're different. They're a different animal, even though they're filled with numbers. You'll see why this is the case as we start to multiply them. So don't freak out if you multiply 2 matrices and then flip it around and multiply again and get a different answer. It's supposed to be that way. That's the way it works. Okay, so I don't want to continue talking about this all day long. I want to get into our first real problem. So what we're going to do, we're going to take this matrix that we've written on the board, both of these here. We've said it's legal to multiply them because the same number of columns equal to the rows of the second one, and we're going to go ahead and multiply that. And the way we're going to do it is just do it by example. Okay. So moving over here, let's rewrite everything. So what we have is 4, 2, 1, and 3 multiplied by the matrix 1, 2, 3, 4, 0, 2, negative 1, and 6. And what you're going to have to do, actually I'm going to try to help you out here and give you a little tip. What I really want you to do is memorize a pattern, okay? Once you see the pattern and how to multiply matrix by matrix, it becomes very simple. But if you don't see the pattern right away and you're just trying to read a book, it's going to be confusing, okay? This is the pattern I want you to memorize, or at least become familiar with, okay? What I want you to do is memorize this pattern. It looks kind of like this, okay? It looks like a corner. What I want you to do is start up here and memorize this pattern, over and then down. So what you're going to do, you're going to end up multiplying these, and I'm going to show you how to do it, but you're going to go across this row and then down this column. So you're going to go over and down. Then you're going to move to the next one. You're going to go over and then down. Then you're going to move to the next one, over and down, and so on. And then after you're done doing this across all of these guys here, you're done because you've gone all the way as far as you can. So then you're going to go to the next row in this matrix, and you're going to repeat the process. Over, down, over, down, over, down, over, down. So I'm quite serious now when I tell you or ask you to pause this video right now and look at this matrix and practice to yourself. Over and down. Actually, that's a little backwards here, so I'll start this way. Over and down, 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 over and down. Because every single matrix that you multiply together, you will do that for every one. And if you don't have that memorized, or if it's confusing or foreign, or maybe you're just not very comfortable with it, you won't know what to do. And I'm not going to write anything more down than that. We're just going to start working problems. So just pause it for a second and say that to yourself just a few times, over and down, over, and even if you don't understand what it means, because I haven't told you what to do yet. I'm just showing you the pattern. Now let's work the problem. All right. What do I mean after I say over and down? I want to switch colors. Okay, so let's go ahead and multiply this guy, and we'll see the pattern by doing the multiplication. And after seeing it and doing it a few times, it's not going to be that big of a deal to you. What we need to do is start in this first row here and go over and down. And we're going to work our way across just like I've been teaching you. That's the pattern, but I haven't actually told you what to do. So let me go ahead and write it down and we'll talk about it. 4 times 1. I'm not even going to do the multiplication. I know what 4 times 1 is, but I'm going to write it down like that so that you know what I'm doing. 4 times 1 plus 2 times 0. Okay. Once we finish doing this operation for every little section of the matrix that we're creating, we're going to go ahead and do this multiplication and add. But for the time being, I'm going to leave it written like this to tell you what we're doing. We've gone over and down. 4 times 1 plus 2 times 0. That is what I mean by over and down. The whole business about over and down, all it means is you're multiplying and adding, multiplying and adding, multiplying and adding, multiplying and adding. That's what you mean. And as you do it, you go across and multiply these terms and add these. You've gone over and down. And that's exactly what it is. Now we have completed the operation for this part of the final matrix, for this number in the final matrix. So let's move to the next one. Over and down in this column, okay? So you'll see the pattern after we work it a few times. 4 times 2 plus 2 times 2. We've gone over and down, okay? Okay, let's continue to the next one. We're going to go on and learn the pattern this way. 4 times 3. 4 times 3 plus 2 times negative 1. Okay, we've gone over and down. 4 times 3, 2 times negative 1. And then the last one, going over and down over here, is 4 times 4 plus over and down 2 times 6. Okay, and we're going to have a big matrix bracket over here. What we've done is we have 4 numbers now that we haven't actually done the math for yet, but these are the 4 numbers that are going to be the 4 numbers in our top of our matrix. Now, we're done. We've gone over and down, over and down, over and down, over and down. We can't do it anymore because there aren't any more columns over here. So we stop and we go to the next row and we do exactly the same operations using those. So going over and down, what we have is 1 times 1 plus 3 times 0. Okay, that's over and down for this one. Now we go to the next column, over and down. 1 times 2 plus 3 times 2. And then over and down over here is 1 times 3 plus 3 times negative 1. Over and down, 1 times 3 plus 3 times negative 1. And then the final one over here, 1 times 4 plus over and down 3 times 6. Okay, it is absolutely imperative that you understand the pattern. If you don't, then rewind it right now and make sure that you see the pattern because you really need to understand the pattern. You'll also see it a lot in some of the other problems. We're going to do a lot of problems of this type. So what we've done is we've started at this row here and gone over and down all the way to the end, and when we were done, we went to the next row and we did exactly the same thing. And when I'd say over and down, we multiply the elements here as we go and then we add them. Okay? So at this point it just becomes very simple. You just add these things together. What you're going to have here, 4 times 1 is 4. So I'm just going to go ahead and write it 4 plus 0 just for full disclosure. 4 plus 0. Over here, 4 times 2 is going to give me 8 plus 4 here. Here I'm going to get 12 minus 2, 12 minus 2. And then over here I'm going to have 16 plus 12. That's going to be the end of my bracket there. And then down here I'm going to have 1 plus 0. And then over here, 2 plus 6. And then over here, 3 minus 3. And then over here, 4 plus 18. 3 times 6 is 18, right? Okay, so at the end of the day, what I'm going to have, in the first number is going to be a 4. Second number is going to give me a 12. 8 plus 4 is 12. 12 minus 2 is 10. And then 16, that's going to be 18, 28 over here. And then over here, I'm going to have 1. Over here, I'm going to have 2 plus 6 is 8. 3 minus 3 is 0. And the 4 plus 18 is going to give me 22. And this, ladies and gentlemen, is your first matrix multiplication right here. This is the answer. And notice we got a matrix back. This process yields a matrix. A matrix times a matrix yields a matrix. 4, 12, 10, 28, 1, 8, 0, 22. Okay? And what you really have to do is memorize that over and down thing, because what you're going to do every single time is use that thing. Just like we said, over and down, multiplying, adding, multiplying, adding, multiplying, adding the whole time. Then you go to the next row and do it. And if you had more rows here, you would keep on going, and so on and so on. If you had more columns, you'd be going more and doing it more that direction here, okay? Now, one thing I want to point out, in the very, very beginning, if we look over here, we said in the very beginning that the number of columns of the first matrix that you have must be equal to the number of rows in the second one. Now, I presented that to you because it's important and I wanted to get it out in front of us here. But really, now that you have done at least one little example, you can see why that has to be the case, because look over here. The number of rows here, see, we're going over and down. So what you're doing is, because you're multiplying and adding, you have to have something to multiply by and add it, okay? If you had, you know, for instance, another row here with a third row or a fourth row or a 10th row, a really, really long matrix down like this, then you could start multiplying and going down, but you would run out of things to multiply by. You have to complete, you know, I don't know how to say it other than that, but as you start multiplying, you have to, everything over here has to multiply by something. If you have extra rows, you're gonna have rows down here that aren't gonna be able to multiply with anything here. So as you go over and down, the number of columns here must be equal to the number of rows, so that as you multiply and go down, you multiply everything by something. Okay, and that is why matrix multiplication is a little bit confusing at first, that they have to have certain shapes and sizes in order to do it, and it's kind of confusing at first. Why does it have to be like that? Well, it's because it's defined this way. Now, the final question I'll really not going to be able to answer, but I'll give it a shot, is most people, when they learn this, the very first thing you ask yourself, or you should, is why is it done this way? Why? Please tell me, why is it done this way? Because when you learn how to add numbers together, 2 plus 6, I mean, you can get 2 jelly beans and 6 jelly beans and add them together, and you can get some number of jelly beans, and you can subtract and you can multiply, and you can visualize those things, because we can use our pencils or our fingers or jelly beans or whatever you want to call it, okay? We can visualize that. That's something we're very comfortable with. This matrix stuff, it's kind of outside the realm of visualization, really, okay? You use them to solve very important problems. You use them to solve algebra problems and calculus problems and everything else, and way into advanced mathematics. Matrices are very, very pervasive all through areas of math. Very, very useful things, but they're kind of outside the realm of understanding. If you want to know the truth, do I really know what this matrix times this matrix really means? Not really. No, I really don't, okay? I don't really know that this is equal to the multiplication of these two things. I do not visualize that. I have no capability to do that, okay? I'm not telling you to give up. I'm always wanting you to ask those questions of yourself, to push yourself. But at some point, you need to accept that some people smarter than you and I have come up with methods to do this multiplication that happens to be useful mathematical operations that we can use to solve problems, okay? That's really what it comes down to. Can I go into and really design my own computer? Do I know how to do that? Do I know how to go and design computer chips that can actually process information and do that? I do not have the intelligence or the capability to do that. I cannot do that. But someone else has done that. So I can go to the store and I can buy a computer and solve problems. I can go and get on and do all kinds of things on a computer and really help me as a tool to solve problems. This matrix multiplication is defined in a certain way. It's defined by mathematicians to be a useful mathematical tool that's useful for solving problems. It's not something that you're going to wake up in the morning and understand exactly why it's defined this way and then have this revelation. What you need to do is learn how to do this so that whenever you're confronted with the problems, you can pick up that knowledge that other people have derived before you and use it as a tool, just like that other example with the computer. So that's how I look at it anyway. Always push yourself, always try to understand why things are the way they are. Don't give up on that. I'm just saying that don't get too hung up on why is it defined that way. Just tell me why, tell me why. You're probably not going to get a great answer at this point on why, but that's how it's done. So let's go ahead and work several other problems and get the hang of doing this. Let's go ahead and work a bunch of problems so we understand that. And let's go ahead and, like we said, A times B, matrix A times matrix B is not usually the same as matrix B times matrix A. Let's prove that. Let's go ahead and write some problems on the board and do the multiplication both ways and show ourselves that it is usually actually not the case. Okay, now the next problem we're going to do is what we want to do is we want to find matrix A times matrix B, and we also want to find matrix B times matrix A, and we want to go ahead and see, are those two in general equal? And we already know they're not equal. I've told you that. Let's go ahead and prove that to ourselves. Let's say matrix A is written as 1, 2, 3, 4. It's just a simple 4 columns, 1 row matrix, and matrix B is written as a column matrix. 1, 2, 3, and 4. It's got 1 column but 4 rows. Okay. Now the first thing we want to do is let's go ahead and find A times B. Matrix A times matrix B. So let's just write them there and let's see if we think these things are legal to multiply together. That's the very first thing you really always should do. You really need to write it down and make sure that the right number of rows and columns exist in order to let you multiply them together. 1, 2, 3, and 4. Okay. Now the question. Okay. The number of columns of the first matrix should equal the number of rows of the second matrix. That's what we're really looking for. And if you forget that little rule, all you have to do is go and trace with yourself. Can you go over and down? That's really all you need to ask yourself. Can you start multiplying and go down and make all of these numbers here multiply by a given number over here? If there's extra numbers here, then the matrices cannot be multiplied together. And so you need to ask yourself the question. So as I trace my finger and go across, I've got 4 numbers here and I've got 4 numbers here. So I can do the multiplication, okay? And what's the answer here? That's the question. This may look a little tricky to you because it's just a single row and 4 columns over here and I should say a single column over here and a single row over here. So what's it going to be equal to? Let's go ahead and write it down here. Well, let's go over and down. Let's see what we have. What we're going to have is 1 times 1. Let me go and write it down explicitly, plus 2 times 2, plus 3 times 3, plus 4 times 4. Over and down. We've used every number with every corresponding number and we've added them together. Now, this is just simply one number. Multiply, 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 but they're all added together. You're going to get one number here, okay? Let me ask you this. Is that where we stop? Is that it? Is there any more to do? Well, you see, there's no additional columns over here. If there were, then I would continue going over and down, over and down, over and down, but there are no more columns here. If there were additional rows here, I would go down and go over and down, over and down, over and down, but there aren't any. Because there's only 1 row and 1 column, this is the only thing I can do. There's nothing more to do after I go over there, so I'm done. Basically, you can keep the bracket. 1 times 1 gives me 1. 2 times 2 gives me 4. 3 times 3 gives me 9. 4 times 4 gives me 16. And when I do that, I have to keep the brackets there, and when I do all of that, I'm going to get 30. 9 plus 16 plus 4 plus 1 gives me 30. Now, it's very, very important for you to understand the brackets must stay here. This is a matrix. It's a 1 by 1 matrix. It just so happens that it has 1 number inside, okay? But you don't want to write on your test that the answer is 30. just as a number, because that's, even though there's one number in this matrix, it's very important that you keep the brackets here to show yourself and remind yourself that this was a result of matrix multiplication. This is a matrix of one row and one column. And what does it mean? Again, just like the discussion before, it means that whatever equation or problem that you're solving, when you multiply these things together, it gives you a one-by-one matrix with that answer. This is useful for you to solve real life systems of equations, but why does it equal one number? Why does it equal 30 and not 31? It's a product of how the matrix multiplication is defined. So I want you to remember that A times B, this matrix 1, 2, 3, 4 times 1, 2, 3, 4, gave us the number 30. Okay, gave us the number 30. Now I want to see what happens if we go in reverse. Okay, I want to see what happens if we go in reverse. And so to do that, we're going to go to the other side of the board here. I want to find out what B times A is. Okay, what B times A is. Now if you remember, B, you have to write them the same way. 1, 2, 3, 4. However the matrices are oriented, you have to write them that way. A was written as 1, 2, 3, and 4. So this is B times A, and I really want to know what this equals because I'm curious if they're actually equal to the previous answer, and we know that they're not going to be, but let's figure it out. First thing you should always do is see, can you multiply these matrices together? Thing you have to ask yourself is, do the number of columns of this matrix equal the number of rows of this matrix? Well, I've got one column and one row, so I should be able to multiply them, and even if you forget that little rule, you just start at the top and try to go over and down. Well, there's only one number here, over, and one number going down, over and down, over and down. So I can do the multiplication. I'm going to hit all the numbers as I go. It's not like I'm going to have extra rows or extra columns. So it seems like I'm able to do this. Okay. Let's see how it would look as we start to actually do the multiplication. Okay. So we're going to put a little equal sign here, and we're going to draw a matrix. Now let's start up at the top. Over and down. All you're going to have is 1 times 1. There's no addition going on because I've gone over and down. There aren't any additional numbers here or any additional numbers multiply. I've gone over through here through one number and down through one number. I'm done with that number. So I got to move on to the next number. Over and down. 1 times 2. Over and down. 1 times 3. Over and down. 1 times 4. Okay? So I've gone over and down, over and down, over and down, over and down, all the way to the end. There's nothing else to do. I just need to start over on the next row. Over and down. 2 times 1, 2 times 2, 2 times 3, 2 times 4. Again, I'm all the way done with that guy, so I go to the next row. 3 times 1, 3 times 2, 3 times 3, and 3 times 4. I think you see the pattern now, going over and down, over and down, over and down, over and down. And then finally, 4 times 1, over and down, 4 times 2, 4 times 3, and 4 times 4. Over and down, over and down, over and down. So now you can see even without doing any more multiplication that this is a real live matrix. I mean, this is a 4 by 4 matrix. It looks not only different than the previous answer, but completely different. It even has a different shape to it. Okay, so let's finish the math here and talk about it a little bit. 1 times 1 is 1. You're going to have 2. You're going to have 3. You're going to have 4. 2 times 1 is 2. 4, 6, 8. Just doing these multiplications. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 4 times 1 is 4. You're going to have 8, 12, and 16. So you're going to have 1, 2, 3, 4, 2, 4, 6, 8, 3, 6, 9, 12, 4, 8, 12, and 16. All right, now let's take a gander at this and see. Let's compare the two. Over here, matrix A times matrix B was equal to a number, a single, well, it was equal to a matrix with one number inside, 30. That was the answer. Okay. Over here, we just simply we flip the order of it, and we get not only something different, but completely different. It's not one number inside of a matrix. It's a 4 by 4 matrix. Okay. So literally, when we say that A times B, matrix A times B is not equal in general to B times A, we don't necessarily even mean that the numbers are different inside. We mean that the entire shape and size of the matrix can be different. And you can see why it's the case. It's just an artifact of the way the multiplication is defined to be, which I'm not asking you to have a great insight into at this point, why it's defined as over and down. That, I'm telling you, is the way it is. But if you take that to be fact, then what you can see is because of the shape of the matrices, going over and down is going to, in general, yield a different type of matrix when you flip the order. So it's different than numbers. 2 times 3, 6. 3 times 2, 6. You can flip the order, it's fine. With matrices, that's not the case. So let's continue working a few more of these, and we'll just flip the order, and we'll prove to ourselves that in general it is indeed different. Okay, so the next problem we're going to have matrix A. Let's just pick a nice 2 by 2. 1, 3, 5, 3. Okay, 1, 3, 5, and 3. And matrix B, let's pick to be another 2 by 2. 3, -2, -1, and 6. Okay, and those are two matrices, and what I want to do is calculate A times B and B times A, and let's see if they're equal, and you already know that they're not going to be equal. Okay, so matrix A times matrix B. What is it going to be equal to? Let's go ahead and draw a little bracket. What we're going to do, let me go ahead and just rewrite the matrices. It'll make it easier. 1, 3, 5, 3 multiplied by matrix B, 3, -2, -1, and 6. 1, 3, 5, 3, 3, -2, -1, 6. Okay, first thing you need to ask yourself, can I multiply these things? Is it legal to do that? If I go over and down, it sure looks like it's legal, because if I go through two numbers here, I'm going to go through two numbers here, and so because those are equal, I'm fine. Also, another way to look at it, the number of columns here equal to the number of rows here, so that's sort of the rule of thumb you have to remember, okay? So let's go ahead and do that. For the first position, I'm going to have, going over and down, I'm going to have 1 times 3, and at this point, you know, up till now, I've been writing it down. 1 parentheses 3. 1 times 3. 1 times 3 plus 3 times -1. I've been doing that. And in the next step, I've been doing the multiplication. And in the next step, I've been actually finding the numbers of the matrix by doing the addition down there, okay? Hang on to that as long as you need to get comfortable with the patterns, okay? But as I go now, it's not really necessarily skipping a step, but the way I'm going to write it from here on in all the other problems is follows. Instead of 1 parentheses 3 plus 3 parentheses -1, I'm just going to write it as 3, whoops, I changed colors on accident. I'm going to write it as 3 minus 3. And as I'm doing that, I'm going 1 times 3 gives me the 3. 3 times -1 gives me the -3. I'm going over and down. I'm doing exactly the same thing as I did before. It's just that I'm doing the multiplication in the first step, because most of us can multiply single-digit numbers together pretty easily, okay? Most of us can multiply 2 times 3 and 5 times 3, etc., okay? So we're going to do that just to save a little bit of room, okay? So going over and down here. Now let's continue. Over and down. 1 times -2 gives me -2. Over and down. 3 times 6 is going to be 18, okay? So I'm going over and down, over and down. There's no more column, so I'm going to go to the next row here. Over and down. 5 times 3 gives me 15. Over and down. 3 times -1 gives me -3. Going to the next one, over and down. 5 times -2 is -10. Over and down. 3 times 6 is 18. I've done exactly the same thing as I've been doing in the other problems. It's just that these numbers, I'm actually doing the multiplication as I go. So when you finish the simplification here, you're going to have 3 minus 3 gives me 0. -2 plus 18 gives me positive 16. 5 minus 3 gives me 12. And -10 plus 18 gives me 8. So I should end up with 0, 16, 12, and 8. That is A times B, matrix A times matrix B. You get a 2 by 2 matrix out of it, and this is the product of those two things. Now let's go over here and let's flip the order B times A and see what we get, okay? So if I'm going to flip the order, I'm going to have B times A, and so B, I'm going to write down from over here, is 3, -2, -1, 6, that's B, and then A is 1, 3, 5, 3. So 3, -2, -1, 6, 1, 3, 5, 3. So I'm going to multiply these guys together and let's see what we get, okay? We're going to go over and down, okay? Over and down starting here, 3 times 1 gives me 3, plus -2 times 5 is -10. Over and down. Now let's go to the next column. Over and down. 3 times 3 gives me 9. Over and down. -2 times -3 gives me -6. Okay? Now I can't do any more because I've gone over and down. There's nothing else to do. Now I'm going to go to the next row. Okay? Over and down. -1 times -1 is -1. Over and down. 6 times 5 is 30. Okay? Now we go to the next column. Over and down. 1 times -3 is -3. 6 times 3 gives me 18. I've gone over and down. Okay? So I've got four numbers, number. Let's just go ahead and do the math. In the first thing, 3 minus 10 is negative 7. 9 minus 6 is 3. Negative 1 plus 30 is 29. And negative 3 plus 18 is 15. So I get negative 7, 3, 29, and 15. And that is the product of matrix B times matrix A. Now let's compare the two. You've got negative 7, 3, 29, 15. You go over here, A times B is a completely different matrix. This so happens to be a 2 by 2 matrix, just as this one is, but the numbers are completely different. So once again, I'm just showing you by example. Multiply matrices in reverse order, it really does matter. So on your test, if they ask you, what is matrix A times B or B times A, you really do have to write the right one first and the right one second, because if you accidentally flip those things, you're going to get not only the wrong answer, the completely wrong answer, and you'll get no credit at all. So let's continue and do a few more. Okay, the next problem, let's go ahead and expand our horizons a little bit, and let's deal with matrices that are a little bit bigger. 4, negative 1, 4, 4, negative 1, 3, 2, 0, negative 2. That's matrix A, and matrix B, let's say, is 1, 1, 0, 1, 2, 4, 1, negative 1, 3. Okay, so 1, negative 1, 4, 4, negative 1, 3, 2, 0, negative 2, 1, 1, 0 for B, 1, 2, 4, 1, negative 1, 3. By the way, I see part of my job here to tell you a little bit of things I've learned over the years, okay? A lot of times you're watching me read from my own notes and write my own problems on the board, and as soon as I write the matrix, I'm usually checking that I wrote the right thing down. Because I'll tell you one thing right now that's happened to me a lot over the years, and it will happen to you too. You'll be in your textbook or on your test, and it says multiply matrix this times this, and it'll be a 3 by 3 or a 4 by 4 matrix for two matrices. And you will screw up and write down one of the matrices wrong, like maybe a 2, you'll turn it into a 3. Maybe you'll forget a negative sign. When I was writing these down, maybe I could have accidentally written a positive 1 instead of a negative 1 there. And there's nothing like your heart sinking when you're on a test and you write the matrix down wrong. Do all the multiplication, which can be, mentally challenging to do. And at the end, you get the wrong answer, and it was only because you copied the problem wrong. Okay, I've done that many, many times. So do yourself a favor when you're doing your homework. When you write the matrix down, please take 10 seconds and make sure you wrote it down right, because I guarantee it will happen to you if you don't, and you'll kick yourself. So that's why I'm doing that, if you're wondering. So let's go ahead and find matrix A times matrix B, and I'm going to go ahead and write them down again just because I want to write them right next to each other, and it helps me. 4, negative 1, 3, 2, 0, negative 2, multiplied by matrix B, which is 1, 1, 0, 1, 2, 4, 1, negative 1, 3. First thing you should always ask, can I multiply these? Is it legal? Well, you have the same number of columns here as the same number of rows, so it seems like it should be legal, but if you want to double check, or if you forget that rule, just go over and down. You go through 3 numbers here, you go through 3 numbers here. It's legal. You're fine. That's all you really have to check, okay? So let's go ahead and get started. Going over and down with this first row and this first column, you have 1 times 1 gives you 1. Going over and down. Negative 1 times 1 gives you negative 1. Over and down. 4 times 1 gives you 4. Okay? So we've gotten our first number here, over and down. I highly recommend to you to at least do it like I'm doing it here, where you're multiplying and you're adding, and you don't actually do it all in one step. It's very tempting for you to actually do this in your head. 1 minus 1 is 0, plus 4 is 4. I put a 4 here. It's very tempting for you, especially when you're starting, to skip steps and do all this math in your head. And if you're good, you're good. But trust me, I don't even do this skipping steps. I don't even skip these steps when I'm doing these on my own work, okay? Because it's impossible to track down your errors if you don't show what you were doing. And you're probably going to make a mistake. So I would recommend to break it out like this, even if it takes more paper. So we've gone over and down. Now let's go to the next column. Over and down. 1 times 1 is 1. Over and down. Negative 1 times 2 gives me negative 2. Over and down. 4 times negative 1 gives me negative 4. Okay? And then over here, over and down. 1 times 0 gives me 0. Negative 1 times 4 gives me negative 4. 4 times 3 gives me 12. So I'm going to have 1 minus 2 minus 4, right. And then, so I'm done here, over and down, over and down, over and down. There's no more columns to go, so I stop there and I go to the next row. Over and down. Let's do it again. 4 times 1 gives me 4. Over and down. Negative 1 times negative 1 gives me negative 1. 3 times 1 gives me the 3. Okay, I've gone over and down. Now let's go to the next column. Over and down. 4 times 1 gives me the 4. Over and down. Negative 1 times 2 gives me negative 2. Over and down. Negative 3 times negative 1 is negative 3. Okay? And then let's go to the last column. Over and down. 4 times 0 gives me 0. Over and down. Negative 1 times 4 is negative 4. And then over and down. 3 times 3 gives me 9. And there's nowhere to go here. There's no more columns, so I go to the next row here and do the same thing. Over and down. 2 times 1 gives me 2. 0 times 1 gives me 0. Over and down. Negative 2 times 1 is negative 2. Go to the next column. Over and down. 2 times 1 gives me 2. 0 times 2 gives me 0. Over and down. Negative 2 times negative 1 is 2. Okay. And then over and down. 2 times 0 gives me 0. Over and down, 0 times 4 is 0. And then finally, you're going to have your negative 2 times 3 is negative 6. So we have number, 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 number. It's going to be a 3 by 3 matrix in the end. So let's go ahead and finish it out. This is going to be 4. 1 minus 1 is 0 plus 4 is 4. And what I'm going to have here is 1 minus 2 is going to give me a negative 1. Minus 4 is going to give me a negative 5. Over here, the 0 doesn't matter, so it's going to be 8. Over here, 4 minus 1 is 3, plus 3 is 6. Over here, 4 minus 2 is 2, minus 3 is negative 1. Over here, 0 doesn't matter, so negative 4 plus 9 is 5. Over here, 0 doesn't matter, 2 minus 2 again gives me 0. Over here, 2 plus 2 is 4. Over here, I'm just going to have the negative 6. And I should be done here. 4, negative 5, 8, 6, negative 1, 5, 0, 4, negative 6. Okay? Now, it's very important that you understand the pattern and realize that that's what we're doing here. You really just need to be methodical about it. You really need to trace your fingers over the matrix as you go and make sure you're hitting everything. And it's a good idea after every one of these to stop and make sure you did it right, because it's going to be pretty frustrating for you to screw something simple up here and just make a simple mistake. So this is A times B, matrix A times matrix B. Now let's go and reverse them, B times A, and let's see what we get just for practice really. We know we're not going to get the same thing. So matrix B times matrix A, reversing everything, is going to be 1, 1, 0 times 1, I'm sorry, next row is 1, 2, 4, and you're going to have 1, negative 1, and 3, and you're going to multiply that by A, which is 1, negative 1, 4, and then 4, negative 1, 3, and then 2, 0, negative 2. Okay, so what we're going to have here is 1, 1, 0, 1, 2, 4, 1, negative 1, 3, and then over here, 1, negative 1, 4, like this, like this. So again, I'm checking myself just to make sure, because it's not fun to get to the end of one of these things and realize that you did something silly. So let's continue on, and it's the same thing. We know we can multiply because going over and down, we go through the same number of numbers, so we know we're going to be able to multiply them and do just fine. So let's go over and down. 1 times 1 gives us 1. 1 times 4 gives us 4. 0 times 2 gives you 0. Okay, that's one number. Going over and down. 1 times negative 1 gives me negative 1. 1 times negative 1 gives me negative 1. 0 times 0 gives you 0. That was over and down. So let's do it again. Over and down here. 1 times 4 gives me 4. 1 times 3 gives me 3. 0 times negative 2 gives me 0. Okay, we're done because we don't have any more columns, so we're going to go to the next row. Over and down. 1 times 1 gives me 1. 2 times 4 gives me 8. 4 times 2 also gives me 8. Okay, that was over and down. So let's do this one. Over and down over here. 1 times negative 1 is negative 1. 2 times negative 1 is negative 2. 4 times 0 is 0. That was over and down. Okay, now let's do the last one, over and down. 1 times 4 gives us 4. 2 times 3 gives me 6. Over and down. 4 times negative 2 gives me negative 8. Okay, we're done with that one, so let's go to the next row. over and down. 1 times 1 gives us 1, plus 1 times 4 gives us negative 4, plus 3 times 2 gives you 6. That was over and down. That's what we just did there. Okay? And then finally, in the next one, we're going to go over and down. 1 times negative 1 gives me negative 1. Negative 1 times negative 1 gives me positive 1. Over and down. 3 times 0 gives me 0. We're done with that one. Finally, last one to do, over and down. 1 times 4 gives us the 4. Negative 1 times 3 gives us negative 3. 3 times negative 2 gives us negative 6. Okay? So we finally have enough to actually see if we can solve this thing. Okay? So let's just do the math. 1 plus 4 gives me 5. This is going to be negative 2. That's going to be 7. Over here, 8 plus 8 is 16. Plus 1 is 17. Over here, you're going to have negative 3. Over here, 4 plus 6 is 10. Minus 8 is going to give us 2. Over here, 1 minus 4 is going to give us negative 3. Plus 6 is going to give us the positive 3. Negative 1 plus 1 is going to give us 0. And then over here, 4 minus 3 is 1. 1 minus 6 is negative 5. So that should be our answer. 5, negative 2, 7. 17, negative 3, 2. 3, 0, negative 5. Okay, and that is actually B times A. Now let's go ahead and compare the two. You have 5, negative 2, 7. 17, negative 3, 2. 3, 0, negative 5. Over here, again, we have a 3 by 3 matrix, but flipping the order, we have a completely different set of numbers inside. So these numbers, these matrices, I should say, the product of these things, when you flip the order, it's a completely different matrix that comes about and a completely different meaning, okay? So we've learned how to multiply matrices. We've learned that you can flip the order of them and get different answers. We're going to work just a few more problems and just show you a couple more things and get you comfortable with doing a few more operations on top of the simple multiplication. Okay, so for these problems, I'm going to give you 3 matrices, and you'll see why in a minute. Matrix A is going to be looking like this: 4, 0, negative 3, 5, 0, and 1. That's a matrix. Okay. Here is a different shape matrix. It's going to be 5, 1, negative 2, negative 2. Okay. And then C is a third matrix, so we're going to get into a little bit different kind of problem, but really it's the same skills. 1, negative 1, negative 1, and 1. So we have 3 different matrices, and what I'm going to ask you to do is let's calculate the following thing. Let's find B times C plus C times B. Okay? B times C plus C times B. So for this particular problem, we're not actually going to use matrix A. We're going to use matrix A in the next part of the problem. So for now, what I want to show you is you can write little relations like this just like you can for, equations. Matrix B times matrix C is going to return a matrix. Matrix C times matrix B is going to return a different matrix. And you can add these together and you'll get another matrix out of it. So the first thing you're going to do, just like if this were, numbers, 2 times 3 plus 3 times 2, you know that you do the multiplication first and then you add the results. So you know that because you've been doing algebra for a while. It's the same thing with matrices. You want to do the matrix multiplication first and then you add them together at the end. So what we want to do is find B times C plus C times B. So the way I'm going to do that is we're going to say equals, what we're going to do is we're going to find B times C. So let's go ahead and write B times C down. Make sure we have our things written here. B is 5, 1, negative 2, negative 2, okay? And C is 1, negative 1, negative 1, 1. This is B times C, and then we're going to add to that, hopefully, C times B. So we're going to have 1, negative 1, negative 1, and 1 times B, which is 5, 1, negative 2, negative 2. So this is a multiplication that's going to give me a matrix back. This is a multiplication that's going to give me a matrix back. And when I get those 2 matrices, I'm going to add them, and we already know how to add them. Adding matrices is very, very simple. Okay? So let me go ahead and switch colors just to make it a little bit easier, hopefully, to read. Now let's go ahead and do this first multiplication here. It's only a 2 by 2, so it's not going to be too terribly hard. We're going to go over and down. Okay? Over and down. So let's do that here. Going over and down here. 5 times 1 gives me 5, plus 1 times negative 1 is going to give me negative 1. So it's 5 minus 1. We went over and down. Now let's go to the next column. Over and down. 5 times negative 1, negative 5, plus 1 times 1 is 1. Okay? So we're done with that. Now let's go to the next row. Negative going over and down. Negative 2 times 1 is negative 2. Over and down. Negative 2 times negative 1 is plus 2. Okay, now we go to the next one. Over and down. Negative 2 times negative 1 is positive 2. Plus negative 2 times negative 1 is negative 2. Over and down. Okay, that's what we did right there. And we're done with that. So let's go ahead and add to it whatever we get from the result of this matrix multiplication. So we're going to go over and down again. 1 times 5 gives me 5. Negative 1 times negative 2 gives me plus 2. Over and down. Let's go to the next column. Over and down. 1 times 1 gives me 1. Plus negative 1 times negative 2 gives me positive 2. Okay? Moving to the next row, going over and down. Negative 1 times 5 gives me negative 5 minus 2, because down like this. 1 times negative 2 gives me my negative 2. Now we're going to move to the final. Over and down. Negative 1 times 1 gives me negative 1. Over and down. 1 times negative 2 gives me my negative 2. So we've done all of our matrix multiplication. This is a number, this is a number, this is a number, this is a number, and so on. So let's go ahead and do this addition down here inside of the matrices and get it all squared away. 5 minus 1 gives me 4. Okay. Over here, negative 5 plus 1 is negative 4. Okay. Over here, you get 0. Over here, you also get 0. Okay. And then what you're going to have here is you're going to be adding to that this matrix. 7, 5 plus 2 is 7. 1 plus 2 is 3. This is going to be negative 7. Negative 5 minus 2 is negative 7. And then over here, you're going to have negative 3. So what we're adding together is 4, negative 4, 0, 0, 7, 3, negative 7, negative 3. Remember back from adding matrices together, you can only add them if they're exactly the same shape and size, which they are. And in that case, you just add corresponding entries. That's all you're doing. Okay? So 4 plus 7 is going to give you 11. Negative 4 plus 3 is going to give you negative 1. 0 plus negative 7 is negative 7, and 0 plus negative 3 is negative 3. So that is the answer. 11, negative 1, negative 7, negative 3. And that would be the answer that you would circle on your paper right there. This is B times C plus C times B. So you see, you can kind of write these expressions that look a little bit like algebra. The thing you just need to be really careful about when you evaluate them is that the matrix multiplication you're trying to do is legal. Okay, make sure it's legal, and make sure that after you do the multiplication that trying to add these things together is legal too. They have to have the same shape and size in order to add or subtract them. So it's going to be up to you to make sure it's the case and make sure you haven't screwed something up, to make sure that what you're doing is legal. So let's do one more. Okay, now for the next problem, what we're going to do is we're going to try to multiply the matrix A times BC. Okay, again, this is one of those expressions from algebra. You know that you can write variables like this, and you know what it means. They're all multiplied together. Usually inside the parentheses, that tells you that from your order of operations that you do always do what's inside of parentheses first. Okay, so when you're looking at this, especially because matrix multiplication is different than regular multiplication of numbers. If these were just numbers, this is multiplied by the product of these two things, so it really wouldn't matter if they were multiplication of numbers, the order. If this were 2 and 3 and 5, it wouldn't matter the order in which I did the multiplication. But because these are matrices, it's very important that you do the order of operations or you're going to get the wrong answer. So here you have to do the inside of the parentheses first. That will give you a matrix, and then you multiply A times that matrix in that order to get the final answer. If you screw up any of these orderings, you're going to get the wrong answer. So it's very important to follow what you're doing. So let's go ahead and find B times C. Okay. B times C is 5 times 1, negative 2 times negative 2, okay, multiplied by 1, negative 1, negative 1, 1. And if you look on the previous board, because we were just solving a problem, B times C, let's see, we were solving B times C plus C times B. We've actually already calculated this matrix over and down, over and down, over and down, over and down. We've calculated it. What we got in the answer was 4, negative 4, 0, 0. If you were to go back just a few minutes, you would see that this is what we actually calculated. So I picked this on purpose so we wouldn't have to do all of this again. This is what we got. Now this is the answer to the inside of the parentheses. So continuing the math here, what we need to do is we need to find A times this, which we just found. So that's going to be equal to 4, 0, negative 3, 5, 0, 1 multiplied by 4, negative 4, 0, 0. And again, it is very important that you do it in this order. A times the product of B, C. If you accidentally flip these around, you may find out that it's not possible to multiply them, or you may just get the wrong answer, just depending on what the matrices are. But here we can multiply them because the number of columns is equal to the number of rows. In other words, as you go over and down, you're going through the same number of numbers, so the multiplication works. So you can do this one. Okay, so let's do it, and let's see what we get. Going over and down here, 4 times 4 gives me 16, plus 0 times 0 gives me 0. Over and down. Let's go to the next column. Over and down. 4 times negative 4 is negative 16, plus 0 times 0 gives me 0. Okay, I can't go anymore because there are no more columns, so I just go to the next row here and continue. Over and down. Negative 3 times 4 is negative 12. Over and down. Plus 5 times 0 gives you 0. And then over and down over here, negative 3 times negative 4 is positive 12. Over and down. Plus 5 times 0 gives you 0. Okay? And then we're done there because we can't go any farther, so we go to the next row. Over and down. 0 times 4 gives you 0. Plus 1 times 0 gives you 0. Over and down here. And then finally, like this, 0 times negative 4 is 0. Plus 1 times 0 is 0. So let's go ahead and simplify this and do all this math. 16 plus 0 is going to give us 16. Negative 16 plus 0 is negative 16. Over here, negative 12 plus 0 is negative 12. 12 plus 0 over here. 0 plus 0 is 0, and then 0 here. That's the matrix. 16, negative 16, negative 12, 12, 0, and 0. And this is actually the final answer of what you would circle on your test. So it's very important. If you tried to do A times B times C in that order, you would get the wrong answer. If you do what's inside first, and then even after we did that, we had to make sure that when we did the final multiplication, A came first, and then the product of what was in the inside, which we had found. We do the multiplication the same way there, and we get the final answer. So that's all I have for this section. Matrix multiplication is very, very important. It's something that really, if you do enough problems, will become natural to you eventually, but it's definitely not natural in the beginning, okay? And that's because there's a pattern to it. So I intentionally said the phrase over and down 35 times. I'm just guessing. You could probably count for me in this section, because you really do need to remember that. And I hope that this repetition has given you that ability. Over and down, just working your way over through the matrices, covering every combination of row and column. That's really what you're doing. You're going through every single combination methodically of every row and every column and multiplying and adding up those things. And when you go through every single combination of row and column, you arrive usually at a new matrix that's defined as the product of those two matrices. The other very important thing that we learned is that when you take a matrix and you A times B and you flip it around and do B times A, those are not usually equal. Okay, and you know, it's just not. So it's totally different than numbers. It's something new to you. So just don't forget about that. Make sure when you're doing your multiplication, you're doing them in the right way. Finally, when you write the problem down, please double check that you wrote it down correctly, because it's easy writing two big matrices together that you might accidentally, you know, write it down wrong or miss a sign or something. And when you're going through over and down, try not to skip, you know, these steps, you know, where I have the additions here and everything, and then finally at the end I do this simplification and do this addition here. It would be very simple as you were working through this. You might get the confidence to just do this in your head. I mean, 16 plus 0 gives me 16. I'm just going to put it there. I'm going to do this one. I'm going to do this one, because these are easy, right? But trust me, when you start doing a lot of matrix multiplication, 4x4 matrices and on bigger from there, you're going to get your brain flooded with numbers, and it's just a matter of time before you make a mistake. So do yourself this favor, plus it helps your teacher give you partial credit if you do screw up a sign error. They can help you. If you just put numbers in the answer, there's no way anyone can ever know what you were doing or thinking. So that's important there. So practice this stuff. It's very important. We will get additional practice as we work through the class, because matrix multiplication is so basic to everything else. You're going to get practice with it as we go on to the other topics. So practice it. You'll get good at it once you see the pattern, and I hope that this lesson was able to reinforce that for you here.